Welcome, my students. Today we have a project of grade 8-9. First of all, I'd like to know the names of the students.
Mazen Ala.
Okay.
Rayana Shamari.
Welcome both of you. First of all, what is the name of this project?
This is the axial flow turbojet.
Okay.
The real version of the model is called the General Electric J79.
Okay.
It is used for many fighter jets, bomber jets, supersonic cruise missiles, stuff like that. It's not a commercial jet, so you can't use it on like planes and stuff like that. Only for jets.
Okay, that's very good. If I talk about the 3D printing, you did it from scratch. Okay, that's fantastic. If I talk about the theory behind all the physics behind, who will go for it?
Probably me.
You?
Yeah.
Okay. Could you explain how it works?
Sure. So now we're going to go for the explanation. In here, there's a startup motor that it starts up the turbines. This starts moving, which would move this in turn. Air would go through here, okay, and it would not be able to get out from here. This would compress the air, and then all the pressurized air would go into here. In here, these vents combine the hydrogen fuel with the oxygen. When they are combined, they are ignited. All the ignition flames go out from here, and this spins like really fast. So it's kind of like a turbo to this. That's why it's called turbojet. Same thing here. That the ignition flames pass through here, which makes this spin even faster. So it makes it more efficient. Then everything comes out of here, like all the flames and stuff. If we open here, in here there's an afterburner that basically takes all the extra hydrogen fuel and oxygen and burns it to give it like a big boost. That's it. That's basically the physics behind it. In here, there's like axle that connects this to this and this to this. That's it.
I would like to thank all of the students that introduced this wonderful project today. Actually, I'm so happy because we did it from scratch. You 3D printed everything apart on it. Okay, you did a wonderful job, Shamari and Mazen. Thank you very much. I appreciate it.